Hello, and welcome to this video about the illustrated library of renewable energy and motor control. In this video, we will explore the different sections of a library and how they can facilitate the design and simulation of projects in the field of renewable energies. The Renewable Energies Library is divided into three main sections. In the first section, we find environmental components that represent the energy sources we extract and other natural parameters that affect the system, such as wind, temperature, or irradiance. The components are essential for simulating real conditions and evaluating the performance of our systems under different environmental conditions. The second section includes the mechanical components for wind energy, such as the turbine transmission. These components allow us to simulate the internal functioning of wind turbines, including the mechanisms essential for generating energy from the wind. Understanding how these components work and how they interact with each other is crucial for designing efficient and reliable systems. Additionally, we have a section with electrical components that include solar panels, batteries, and other essential devices for our circuits. These components are vital for generating, storing, and distributing energy in solar and wind systems. We also include passive elements and other components that allow us to represent energy consumption. All of this is presented in an illustrated manner, facilitating understanding and use in projects. We also have components such as the cup anemometer, which measures wind speed, essential for wind energy systems. Now we will look at two examples of systems built with elements from this library. The first example shows the functioning of a wind turbine producing energy to be consumed by a household, equipped with batteries that allow storing a certain amount of energy. When starting the simulation, we observe how the wind effect acts on the wind turbine, and by connecting the clutch, we allow the transmission, passing through a gearbox with a ratio from 1 to 10 to the three-phase generator. By using switches, we can change the functioning or the consumption and observe what the effects are. The second example contains a series of solar panels connected to a battery charge controller, which in turn is connected to a battery and to the alternating current consumption consisting of lights and a radiator. We also have a graph that shows how much power we have generated by the total solar panels and what the state of the charge is over time. We can see that even if we turn on the light switches, we don't have electrical current, because the charge controller is diverting the energy to the battery until it reaches an optimal charge level to then divert the energy to consumption. We also see the irradiance oscillations that we have previously defined to simulate the effect of clouds. Using this illustrated library has numerous benefits. It allows us to visualize each component clearly and precisely and its functioning, which facilitates the identification of problems. Additionally, using illustrated components makes the simulation more intuitive, allowing engineers or technicians to better understand and learn the system behavior. For more information about Automation Studio software, we invite you to visit our website. Thank you very much for watching this video.